Okay, class, we are going to begin a series of lessons in trigonometry. And in this lesson, you are first going to learn to use trigonometric functions. Okay, so let's go ahead and get started and first define what the trigonometric functions are. So we're going to start with this triangle. Okay, this is a right triangle. And we have this angle here, theta. Okay, so everything is going to be off of this reference angle, theta. Okay, and we in Greek letter we use the letter theta to represent acute angles. Okay, and so relative to this angle, we have this side of the triangle, which we call adjacent. Okay, so this is the adjacent side. Okay, now opposite this angle is the side of the triangle, which we label opposite. Okay, and then the side opposite of the right angle, well, we will always call the hypotenuse. Okay, so the six functions are as follows. We have sine, then we have cosine, then we have tangent, secant, cosecant, and tangent. Okay, these are the basic trigonometric functions. Okay, so if we were to take the sine of theta, okay, the sine of theta is going to be equal to the opposite side divided by the hypotenuse. Hypotenuse. Okay, so the sine of this angle is going to be the opposite over the hypotenuse. Next, we have the cosine of theta, and that's going to be equal to the adjacent side over the hypotenuse. Okay, so the cosine of this theta is adjacent over the hypotenuse. And then the tangent of that angle is equal to the opposite over the adjacent angle. Okay, so the tangent of this angle theta is going to be the opposite over the adjacent. Okay, and when we talk about opposite and adjacent and hypotenuse, we're talking about the length of each of those sides. Okay, so we've established three of the six. Okay, now notice the next three. Okay, notice that there's a pattern. So let's take a look at the secant. Okay, the secant of that angle theta is going to be the hypotenuse over adjacent. Okay, hypotenuse over adjacent. Now, let's pause here for a second. Where in the first three trigonometric function do we have hypotenuse and adjacent? Okay, and it's right here. The cosine of theta is adjacent over hypotenuse. And here we have secant theta is hypotenuse over adjacent. So what this means is the inverse of cosine gives us secant. Likewise, the inverse of secant gives us cosine. Okay, it's very important to understand and see that relationship because this will become useful later on, not in this lesson, but in future lessons. Okay, so let's go ahead and move on. Then we have the cosecant is equal to the hypotenuse over the opposite. Okay. If you notice, the sine of theta is the opposite of over hypotenuse, and the cosecant is hypotenuse over opposite. They are the exact inverse. Okay, so the inverse of sine of theta is equal to the cosecant of theta. Sorry, I forgot to put the theta there. And likewise, the inverse of cosecant theta is the sine of theta. Okay. Now, lastly, we have, oh, I apologize, this should be cotangent. So let's go ahead and call it cotangent. Okay, and the abbreviation for cotangent is COT, and the cotangent of theta. Okay, and you might have guessed it by now, it's going to be the inverse of tangent. So in other words, it's going to be adjacent over the opposite side. Okay. All right. So those are the 6 trigonometric functions. Okay. And one thing that I want to specify is that there's actually an easy way to remember these first 3. Okay. And it's called SOHCAHTOA. Okay. SOHCAHTOA. SOHCAHTOA. And the letters are acronyms for each of the functions. Okay, so in other words, so means that S, which is sine, this is the first letter of sine, S is equal to the opposite over hypotenuse. Opposite over hypotenuse, OH. Okay, this next 3, the cosine, C, starts with the letter C, is equal to the adjacent over hypotenuse. Okay, cosine is equal to the adjacent over hypotenuse. So notice it's the first letter of each of these words. Okay, so we got sine, opposite over hypotenuse. I should probably notate this in a different color so you can see this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then lastly, we have tangent is equal to opposite over adjacent. Okay, tangent is equal to opposite over adjacent. So if you can remember SOHCAHTOA and recognize the acronyms, then you will have established and remembered the first 3 trigonometric functions. Okay, then if you know this first 3 and you recognize and remember that these are inverses of these 3, okay, not necessarily in that order, but if you realize that these are inverses of these 3, then you have all 6 memorized. Okay, so hopefully that'll help you understand all 6 basic trigonometric functions that we've written out here. Okay, so let's go ahead and start with example number 1. Okay, example number 1 says, given the right triangle below, so right over here, we're going to write the 6 trigonometric ratios for the given angle theta. Okay, so this is my theta. So let's start with the first one. Okay, if we follow SOHCAHTOA, let's go ahead and write this out. SOHCAHTOA. Okay, first we're going to say the sine of theta is going to equal opposite over hypotenuse. Opposite over hypotenuse. So that ratio is going to be 21 over 29. Okay, so that's function number 1. Function number 2 is going to be the cosine of theta, and the cosine is going to be the adjacent over hypotenuse. Okay, cosine is adjacent over hypotenuse. So that means we have 20 over 29. And then the next one is the tangent of theta. Okay, TOA, tangent is opposite over adjacent. It's going to be opposite over adjacent. Okay, so that's going to equal 21 over 20. All right, so now we've established the first 3 of the 6 trigonometric ratio. Now we're going to go to the other three. And the other three are secant, okay, cosecant, and cotangent. Okay, and if you recall, the secant of theta is the inverse of the cosine of theta. So all we have to do is take this ratio and flip it around. So this becomes 29 over 20. Then let's go to the cosecant. Cosecant is the inverse of the sine of theta. So all we need to do is flip this around. So this becomes 29 over 21. And then lastly, cotangent of theta is the inverse of tangent of theta, which means we just need to flip these around. So then cotangent of theta here is going to be 20 over 21. Okay, so here are the 6 trigonometric ratios for example 1. Let's go ahead and go on to example number 2. Okay, so we're going to take this up a little bit or to the next level of difficulty. Here it says that knowing that tangent of theta is 15 over 8, what are the other trigonometric ratios? Okay, so we've got tangent of theta, okay, and that's 15 over 8. Okay, so let's go ahead and write SOHCAHTOA. SOHCAHTOA. Okay, tangent of theta. Tangent means opposite over adjacent. Opposite over adjacent. So we can go ahead and label these. Opposite, this is going to be 15, and adjacent is going to equal 8. Okay, so we have 15 and 8. Now all we need to do is to solve for hypotenuse, and once we have that, we can establish the remaining 5 trigonometric ratios. Okay, well, how do we do that? Well, to find the side, we use the Pythagorean theorem, and the Pythagorean theorem states that a squared plus b squared is equal to c squared. Okay, well, we can call this side A and we call this side B. You can also call this side A and this side B. It doesn't matter. The ultimate thing is to find the length of C. Okay, so we want to know what this length is. So remember that this is going to be c squared. Okay, so the value of c is going to be the square root of both sides. So we need to square root both of these. And c then becomes the square root of a squared plus b squared. Okay, well, what is a squared? This is going to be, let's call this a. This is going to be 8 squared. Call this 8 squared plus, my b is going to be 15. So we're going to square 15. And we see that that is equal to c. And therefore c is going to be the square root of, let's see, 8 squared is 64 and 15 squared is 225. Add those together. We're going to get the square root of 289. And this works out to, if we punch that into the calculator, square root of 289 is 17. Okay, so now we know this is 17. Okay, so now we know the length of all 3 sides of the triangle. We can now solve the ratios of the remaining 5 trigonometric functions. Okay, so let's go ahead and start with sine. Sine of theta is going to be opposite over hypotenuse, so that's going to be 15 over 17. The cosine of theta is going to be adjacent over hypotenuse. We already have tangent, so we don't need to write that down. We can go to secant of theta. Secant of theta is the inverse of cosine, so we know that's going to be 17 over 8. Cosecant of theta is the inverse of sine, so that's going to be 17 over 17 over 15. And then cotangent of theta is going to be the inverse of tangent, so that's going to be 8 over 15. 8 over 15. Okay, so those are our answers for example number 2. So let's go ahead and move on to example number 3. Here we have a word problem, and it tells us that a fire truck has an 84-foot ladder extended against a building, forming a 55-degree angle with the top of the truck, of the fire truck. And we're told that the truck is 8 feet tall. And the firefighters are trying to reach a window that is 75 feet above the ground. And the question is, will they be able to reach the window using the ladder set at this angle? Okay, so let's go ahead and whenever we're dealing with word problems, okay, it's really important to sketch this out. So let's go ahead and draw a building. And they're trying to reach a window. That is 75 feet above the ground, okay? So let's say the window is right here. Okay, and it's 75 feet, okay? So let's go ahead and mark that. From here to here is 75 feet. All the way down to the ground. Okay. So we've established that 75 feet above the ground, and we also have a fire truck. So let's go ahead and draw a very simple fire truck. Okay, so we got a fire truck here. It's got wheels. Okay, now we're told that the truck is 8 feet tall. Okay, so let's go ahead and label that. So from here to here is 8 feet. Okay, that's 8 feet. And we have a ladder. Okay, we have a ladder, 84-foot ladder that is extended against the building, forming a 55-degree angle with the top of the truck. Okay, so let's say this is the ladder. Okay, and this is 55 degrees right here. Okay, 55 degrees. This is a 55-degree angle with the top of the truck. Okay, and we're told that this is 84 feet. Okay, so we can go ahead and just draw a dotted line here so that we recognize that this is actually a right triangle. Okay, whoops. Let's go ahead and draw this again. There's the right triangle. Okay, so hopefully this diagram is accurately depicting what is being told to us in this word problem. And the question here, okay, always keep the end in mind, is will they be able to reach the window using the ladder set at this angle? Okay, set at this angle. Okay, so first off, we need to figure out what this distance is. Okay, we need to know this because we have this angle here and we need at least two sides of the triangle. We have this 84 feet. We're not going to know this distance. We don't have any information there, but we do know the height. So we know that the height of the window is 75 feet. So from the ground up is 75 feet, but we know that this distance is 8 feet, okay, from the ground to the top of the truck, which is where the ladder begins. So then 75 minus 8 is 67 feet. Okay, so let's go ahead and label that. So then from here to here is 67 feet. Okay, so now we've got two sides of the triangle. All right, so relative to this angle, if we think about our trigonometric function, relative to this angle, we have the opposite side and the hypotenuse. Now, which function has the opposite side and the hypotenuse? Well, let's go ahead and write our SOHCAHTOA. Okay, And we are looking for opposite and hypotenuse. Okay, where is that? Opposite and hypotenuse. So we're going to be dealing with a sine function. So then let's go ahead and establish that. The sine of 55, okay, is going to be the ratio of 67 over 84. Okay, now we figured out that the height is 67. Okay, this is what is needed, but what we really need to do is to figure out, is the ladder going to be high enough? Okay, so then we really need to do is solve for this length here. Okay, we want to know if this is going to be long enough. So then we have to replace the 67 with x. We're going to just say, we're going to call it x. Okay, so let's go ahead and delete that, and we're going to call this x. Okay, so let's go ahead and solve for x. So in order to solve for x, we have to move 84 over to the other side of the equation, and we do that by multiplying both sides by 84. Okay, and when we do, these cancel out, and we get x is equal to 84 times the sine of 55. Okay, and if we punch that into the calculator, we find that the sine of 55 times 84 is equal to 68.8 feet. Okay, so at this angle, what this is saying is that at this angle, okay, this ladder will be 68.8 feet, okay, from this elevation. And since 68.8 feet is greater than the 67 feet that we need, okay, so since 68.8 is greater than 67, then we will be able to reach the window. Okay, so that is our answer. Or you can just say yes. Okay, so let's go ahead and move on to example number 4. All right, so we're told that triangle MNO, which is right here, MNO, is a 45, 45, 90 triangle. Okay, that's going to be key, and we'll come back to this. And the side length of OM is equal to 2. So this length is 2. And the question is, what are the 6 trigonometric ratios for angle N, okay, theta, with measure theta? All right, so if you recall from geometry, when you have a 45, 45, 90 triangle, okay, meaning that this is 45 degrees here, and this is also 45 degrees. When you have that scenario, okay, and we know that we're given that MO, the side length is 2, given a 45, 45 degree triangle, we also know that this side length is also 2. ON is going to be 2. Okay. Now that we know that this is 2 and this is 2, we can use the Pythagorean theorem to solve for the length of side MN. Okay. So Pythagorean theorem, as we said earlier, was a squared plus b squared is equal to c squared. And to solve for c, we have to square root both sides. And we get c is equal to the square root of a squared plus b squared. Okay, well, it doesn't matter what is a or b because both are the same, so we're going to go ahead and plug that in. That's going to be square root of 2 squared plus 2 squared. That gives us the square root of 4 plus 4. Oops, 4 plus 4, which means c is going to be equal to square root of 8, which simplifies to 2 square root of 2. Okay, so that is our c. So now we know that this length is 2 square root of 2. All right, so now let's go ahead and establish all 6 trigonometric ratios. Okay, here's our SOHCAHTOA. So we start with sine. Sine of theta is going to be, this is our theta, it's going to be the opposite over the hypotenuse. Okay, so that's going to be 2 over 2 square root of 2, which simplifies to 1 over square root of 2, which simplifies to, well, we have to simplify this. So we're going to multiply this by square root of 2 over the square root of 2, which ends up becoming square root of 2 over 2. Okay, so that's our sine of theta. And then the next function is going to be cosine of theta. And the cosine of theta is going to be the adjacent over the hypotenuse, which is the same thing as the sine, 2 over 2 square root of 2, and that's going to equal square root of 2 over 2 without going through the same simplification. Okay, the third one is tangent, right? TOA, and that's opposite over adjacent. So the tangent of theta is going to be the opposite, which is 2 over 2, which simplifies to 1. Okay, then we're going to go ahead and establish the other 3. We have secant of theta, which is going to be the exact inverse of cosine of theta. So that's going to be 2 over square root of 2. 2 over the square root of 2. And to simplify that, we need to multiply this by square root of 2 over the square root of 2. And that ends up becoming 2 square root of 2 over 2, which is equal to square root of 2. Okay, because these cancel out. Now, when we talk about simplifying, your answer cannot have a square root of 2 in the denominator. This is why we go through these steps. Okay. All right. The next one is cosecant of theta. Cosecant of theta is going to be the inverse of the sine of theta, which is the same thing as the cosine of theta. All right. So that's going to be 2 over the square root of 2. And instead of going through all of this calculation, which we've already done, we know that that's going to be square root of 2. And then lastly, the tangent of theta is going to be the inverse of tangent of theta. I'm sorry, not tangent of theta. Cotangent of theta. Okay, cotangent of theta. Cotangent of theta is going to be the inverse of tangent of theta. We know tangent of theta is 1. The inverse of that is going to be also 1. So then we know that the cotangent of theta is going to be equal to 1. Okay, I should put these equal sign, keep these consistent. So our 6 trigonometric ratios are right here. Okay, and I believe that was the last example. Okay. So hopefully that made sense. I know this was a little bit long, and since this is the first foray into trigonometry, you may want to go back to the beginning of this recording and listen to it again to just kind of capture anything that you may have missed the first time around. All right, thank you very much.